All right, for those of you that are just joining us, sorry I forgot to record the lecture over chapter 34, where we learned how to figure out the greatest common factor. And with the greatest common factor, we're just trying to figure out everything that appears in each term. And so like every term here is divisible by 2, so we pulled out a 2. Every term here has at least one x in it, so we pulled out an x. And every term here has at least one y in it, so we pulled out a y and got a GCF of 2xy. All right, so now we're actually factoring. So you're going to have to, if you're not here today, you're going to have to look at lesson 34 on your own and make sure you understand that. We've already determined that the greatest common factor for this term, this expression here, is this. So now, when we say we're factoring it out, we're doing like the reverse of distribution is basically what we're doing. All right. If we look at a super simple example of that, let's say we had 6x plus 2. All right. What would be the GCF of that term right there? 6x plus 2, that expression.
Be 2. No, it'd just be 2.
Just 2, right? There's not an x in both terms. So the only thing that's common to both terms would be the 2, right? And so what is it that I would multiply 2 by to get 6x? 2 times what would give me 6x?
3x.
3x, right? Does everybody see that? See how easy that is? And 2 times what would give me 2?
1.
Positive 2, explicitly. It's positive 1, right? So this is how I would factor out the greatest common factor of that expression. You pull out the greatest common factor, and then you say, what would I multiply it by to get the term that was there? And so when we get done with this one, we get a problem that looks like the type of problems where we had to do distribution. All right? When we factor out. So now let's apply that same thing to something that's a little more complicated. What would I have to multiply negative 2a squared b squared by in order to get this term right here? First, I'm going to look at the numbers. What do I have to multiply negative 2 times to get negative 12? Just 6, right? Because it's negative here, so negative 2 times positive 6 gives me negative 12, right? What about the a's? What do I have to multiply a squared by to get a squared? Just 1, right? B squared, same thing. B squared times 1 gives me b squared. So if I were to write those down, I would do 1 times 1, but we would never write that down. So we just write down 6 for that one, okay? So our first, when we pull the greatest common factor out of our first term, we get that. Now let's look at our second times. How many times will negative 2 go into negative 4? 2 times, right? So a positive 2 times. So we're going to have a positive 2 there. Because negative 2 times positive 2 gives me negative 4. What about a squared? A squared times what gives me a cubed? A squared times a what equals a cubed?
Just A.
Just a to the first power, right? We would just write that as a. Does everybody see that? So we take care of the a terms. A squared times a equals a cubed. B squared times what gives me b squared? B squared times 1, right? So we just leave that out. And then what do we, if we've got a 1 here, since there's no y term, 1 times what gives me y? Well, just y. All right? So let me make sure everybody's clear on what we just did. What we said was that negative 2a squared b squared times 2ay, if we did this correctly, this multiplied together should give us this. So let's see if it does. Negative 2 times negative 2 is negative 4. A squared times a is a cubed. B squared times nothing or times a 1 is b squared. And then 1 times a y gives us a y. So we do in fact get the term here that's exactly the same, right? If we wrote all this out, we would normally write this out as negative 2 times 2, a squared, a, b squared, y, right? That's how we would kind of write all that out and then simplify it to be a cubed, b squared, y. So we can always kind of check it and make sure that we got it right by multiplying this times this and see if we get that term, all right? Let's do the same thing with the last one. Negative 2 times what gives me negative 10?
5.
Positive 5, right? A squared times what gives me A squared times 1. B squared times what gives me B to the 4th?
B 2.
B squared. Forgot to put your name on here, Jonah. You've been jamming Jonah today. So we got B squared, and then we got to take this Y squared into account, so we put that on our term as well. All right. So again, if we did this correctly, we could check it by doing distribution. And if we distributed through by this term right here, we should get our original problem if we did everything right. Right, so that would be a way for you to go back and verify that you didn't make any mistakes. Any questions about that? Now, sometimes when you do this, you'll be able to cancel some stuff out. And I'll show you what I mean by that. That happens whenever you've got some expression over another expression. So let's say we have something like this. This has already, the 4 has already been factored out for us. You guys agree if we had 4x over x, over 4, what would that equal? Somebody said it. Would you say, Ada? Did you say it? No? I heard someone say x. Yeah. Right? We do that all the time when we're solving for x. Like if we had 4x equals 12, and we wanted to see what x was, what would we do? To get the x by itself, we would divide both sides by 4. So the 4's would cancel out, we would say x equals 3. Right? So when we divide 4x by 4, we get the 4's cancel out and we're left with just x. Okay? That's the same kind of thing we have right here. Right? Does everybody see that? So we've got 4 times some value divided by 4. And so our 4's would cancel out and we would be just left with that value that was on top. So you can kind of see when you look at this looks like what we've been doing when we pull out the greatest common factor, right? Sometimes when we pull out the greatest common factor, it'll cancel with something on the bottom of the fraction and it'll simplify our whole expression. So I just want to make sure that that makes sense to you guys. And it could look like this too. We could have something that looks like 3 times x plus 2 over x plus 2. Now this time, what's actually canceling out? X plus 2. Who said that? Ada, right? You guys see that? X plus 2 times something divided by x plus 2. These x plus 2's cancel out and we're left with 3 in that case. Yep.
It was in parentheses, like say you just had x plus 3, and then parentheses x plus 2, and you only had x at the bottom, could you still cross out x?
So what do we have on top? Tell me that again.
3.
3?
X plus 2.
With the parentheses?
Yes.
Okay, so we still have 3x plus 2, and on the bottom now we just have x?
Yes.
Okay, we can't. We can't cancel because we can only cancel if whatever we have on the bottom here is multiplied by everything that's on the top. So we would have to have something like this. This we could do. So what if we had 3x? Remember, when you see something written like that, that's the same as 3 times x plus 2, all that over x. And since this x is multiplied by everything, then we could say this and this can cancel out, and we're left with 3 times x plus 2. Does that make sense? That's a good question. So yeah, if you can only cancel out the thing on the bottom if that thing on the top is multiplied by everything else. Okay? It has to be multiplied. In this case here, when it was just like this, it wasn't multiplied together. It was like added inside the parentheses there. Okay? All right, so let's see something like this. What if we have 3p plus 3 over 3, all right? And they said simplify this. What do you guys think we would do? What would we do on the top? What little trick have we learned? Yes?
Would it be 6p? Or do you add them?
No. What's the first thing we have to do on the top based on what we've just learned about greatest common factors? Let's factor out the greatest common factor in that top term, okay? What can we factor out of 3p plus 3? What's common to this term 3p and to this term 3? 3, right? Both of them are divisible by 3, right? So we could say 3 times what is 3p? 3 times p. And 3 times what is 3? 3 times 1. All right, so does everybody see I can factor out a 3 and get that? Now, what do I have? I have a 3 times something on the top divided by a 3. And that means my 3's can cancel out, and I'm left with just p plus 1. All right, yes?
Could you not just cancel out the 2 3's?
When? Right here?
No, not the 3p, just the other 2 3's.
This?
When you first started, the bottom and the top.
This and this?
Not the one with the p.
Oh, these two?
Yes.
No. This goes back to your other question. Because this 3 is not multiplied by everything, right? It's added to it. You have to have multiplication. Right? If we had this, just think again to the way that we've solved for x before. If I had 4 plus x equals 9, would I divide by 4 to get that x by itself? No. What would I do? If I want to get the x's have the x's on one side and the numbers on the other side, how would I get rid of that 4? Huh? I would subtract 4, right? I wouldn't use multiplication here. I would use subtraction, right? And I would say x equals 5, right? Well, what I've got right here, it would be sort of like you saying that in this case here, I could divide by 4 and get rid of that 4, right? 3p plus 3 divided by 3 won't get rid of that because they're not multiplied together. We only use division to undo multiplication. And this isn't multiplication, this is addition right here. But when we pull the 3 out, now we have a 3 that's multiplied by everything, and that's what allows us to cancel it out using division. Does that make sense? Because what are we effectively saying whenever we have the 3 on the bottom? We're saying we're dividing this whole thing on top by the 3, right? Aren't fractions just simply division? Right? So since 3 is multiplied times this, we can divide out the 3. Okay? We can cancel it out. All right, so you'll have some problems to practice that, and just make sure you do enough problems till you get it down, right? Let's do one more quick one. 3x minus 9x squared divided by 3x. 3x minus 9x squared divided by 3x. We're going to do the same thing right here. What are we going to be able to factor out of our top of our numerator? 3x minus 9x. What is common to each term in there? Does each term have a 3?
No.
It doesn't?
Have an x.
Well, it does.
It goes down.
Is each term divisible by 3, right?
Yeah.
If we break it into factors, each term has a 3 in it, right? So we have each term has a 3, and do you see that each term has 1x? All right, so 3x, we can factor that out. So 3x times what gives us 3x? Well, 3x times 1 gives us 3x. And 3x times what gives us negative 9x squared? 3x times negative 3x. Does everybody see that 3x times negative 3x is negative 9x squared? Right? So that's 3x factored out. Now, what do I have? I have a 3x on top that's divided by 3x on top that's multiplied by everything. And then that's divided by a 3x on the bottom. So these 3x's will cancel out, and we're left with 1 minus 3x. Now again, if this looks weird, this is one of those cases where practice, right? Do your homework problems, and if you still don't have it down, pick some other problems that are similar in the chapter. Look at some of the even problems that are the same and see if you can work those and get the correct answer, okay? Because the more you do these, the more it's going to make sense and get easier for you. All right? All right, last thing, we're going to do the distributive property of rational expressions. Does anybody know what rational expressions are? Rational expressions are just fractions, all right? When we talk about something that's rational, a rational number can be represented by a whole number over another whole number. So a rational number is a fraction, all right? And so let's talk about distribution with rational numbers. How would I do this? How would I do 2 over 3 times 5 over 7? How do I do that multiplication? What's our rule for that?
You
Yep.
just multiply across.
What we
You cancel the ones. Okay, no, you can't go through the rest.
can't cancel anything. So we're back to what Will was saying there. Multiply across. So tell me what the answer would be.
10 over 21.
That's right. So you have to multiply the top and you have to multiply the bottom. Now what Alexa was thinking was if you had something like 2 times 3, 2 over 3 times 6 over whatever. What would we say? 6 over 9. Right? Actually, that's not good.
4.
6 over 8. Let's do that. All right. Then we could cancel. We could say this 2 will go into this 8 4 times. All right. And then we can simplify it like that, and we could get, and we could actually say 3 would go into 6 2 times, and then we're left with 2 over 4, which is 1/2. Right. So you could cancel if it's like that. But the main thing I wanted to get across here is that when you have a fraction times a fraction, you multiply the numerators and you multiply the denominators. Yep. All right, so now we can do that same thing with variables. All right, so what if we have something that looks like this? What if we have the distribution property and we got to use it on a problem that looks like this? It looks complicated, it looks scary, but it's just the same simple stuff that we've been doing. So don't freak out, right? Clearly, we can't combine these terms that are inside the parentheses. They don't have the same variables. It's definitely different. So our rule is when we have distribution, what did we do when we had something like this? We said we couldn't combine the x and the 2, so we have to multiply the 3 times the x, and we have to multiply the 3 times the -2 to get 3x minus 6, right? That's all that we're doing right here, okay? So we have to multiply the first 2 terms together. We're distributing this term here in the front. So we're saying x squared over y squared times x squared over y, right? All of that plus x squared over y squared times negative 3y cubed over m. Same exact thing that we did with distribution when it was simpler, right? We're just multiplying the value outside the parentheses times each term inside the parentheses. Did I lose anybody when I wrote that down? Everybody good with that? All right. So how do we multiply fractions? We say we multiply the top together. What's x squared times x squared?
X 4 squared. I don't know.
X to the 4th.
Yeah.
Right? X squared times x squared is x to the 4th. Y squared times y. What's that?
Y squared.
Y squared times a 1y.
Well, to the
So we would have
Y cubed.
3y's, so y cubed, right? All right, plus, so that takes care of that, this first term here. What about this? What's x squared times a negative 3y cubed? Actually, here's what we're going to do, because we got a plus here and a minus here. We're going to go ahead and just say we know there's going to be a minus in between. So plus and a minus is going to give us a minus, right? So then we don't have to worry about the sign anymore. Yep.
It would be 3x squared y cubed.
That's right. Does everybody see that? There's not really anything that we can combine together. We're just going to rearrange it and write it with the number in the front and our variables in alphabetical order. And then on the bottom, we're going to do the same thing. It's just going to be y squared. Okay? That's it. We're done, right? It looked crazy, hard, but it's not. We're just doing the same thing that we've always done where we distribute through. We just have to remember our rules for multiplying fractions, okay? Does that make sense to everybody? Good. So you'll have an opportunity to do that. Let me just make this clear. What if we had this? What if that had been that term?
Wouldn't you just put it over on top?
Huh?
Wouldn't you just put it on top?
Yeah, just do it on top, right? There's an understood 1 here. So we would multiply x squared times this, and the bottom we would have y squared times 1. Okay, so that's how it would change if you didn't have a number there. Last thing that we want to just very quickly look at is minus signs and negative exponents. And let me just, let's give you an example. This is actually coming directly from your practice set for this homework. How would I figure this out? How would I solve this? Let me ask you this first. What would this be? Let me do it positive. Sorry. What would this be? 4 over negative. 4 raised to the negative 2. How would I solve that?
You make it a fraction by putting the 1 at the denominator and then flip it. Use the reciprocal, and that would make the.
Are you saying that?
Yeah.
Okay. So we get rid of the way that we get rid of negative exponents is we move them to the other side of the fraction, right? So we move it down to the bottom of the fraction. That gets rid of our negative exponent. Now we know how to raise 4 to a positive 2, don't we? So this answer would be 1 over 16. Everybody see that? All right, that's exactly what we do here in this case, right? We would say, let me bring it down here so we've got a little more room. We would say negative 4 raised to the negative 2nd power is equal to, we're not messing with this negative here. Why not? Because exponents only apply to what?
What's directly next to it?
Huh?
What's directly?
What's directly to the left of it, right? We can only touch the negative sign if it was like that. All right? It's not. So the negative power there only applies to the 4. So we're going to rewrite this as we're going to keep the negative in the front, and we're going to say 4. We're going to bring our 4 to the bottom, and we're going to say that's negative 1 over 4 squared. Right? And so that equals negative 1 over 16. Does that make sense? So what about this one, last one? 1 over negative 4 to the negative 3 power. What's our first step? How do we get rid of that negative 3? Power. Move it to the top of the fraction. Oh, you still got one of my calculators. Is that my calculator?
Yeah.
Who else has a calculator? Anybody else? You get the rest of them? Thanks, sir. So we're going to bring our negative 4 to the top to get rid of the, wait a minute. I'm still missing 2 calculators. Are they up here? Yeah, they're right here. Okay, I'm good. All right, so I'm going to bring the negative 4 to the top. So I'm going to change this to this negative sign. We leave it alone. I'm just going to bring it to the front of our fraction. We bring this negative 4 to the top, so we have negative 4 now raised to the 3rd power. And so the negative is affected by the 3, this negative that's inside the parentheses. So this would be the same as 3 times negative 4 times negative 4, negative 4 multiplied 3 times, right? Isn't that what negative 4 cubed is? We could punch that in our calculator too, and we should get 64. So this is negative in the front. Negative 4 times negative 4 is positive 16. 16 times negative 4 is a negative 64. And so then we get positive 64 as our final answer. Okay? All right, that's all I have for today. If you got any questions about that, you're welcome to ask those. Yes?
What's our homework? for this
Your
week?
homework will be just those 3 chapters. So it'll be lessons 34 through 36. And it's the same as always. Practice, all practice. on problem set. And take tests, right? So only 3 lessons this week and take the test. Y'all have a good one.